let's start. Shazan, what is this?
Ma'am, it's water and another is chemical.
It's a chemical. And what is the nature of the chemical? Any
Ma'am,
idea?
it's acidic.
Yes. It can be acidic, it can be basic and neutral. है ना? It can be acidic, it can also be basic and neutral.
Ma'am, it reacts with the surrounding. Some of the chemical reacts with the surrounding.
Like?
Ma'am,
Hmm?
Ma'am, I don't know the example.
Okay, so this is the nature of the chemical. है ना? It can be acidic, it can be basic, or it can be neutral. Acidic, acid and base. So this is the second unit of the 10th class, acids and base. The first topic is the theories of acids and bases. Second is bases, strength of acids and bases, salts, and the laboratory preparation. Okay, Shazan? First, already done the chemical reactions and equations, and this is the acid, bases, and salts. Now, here, if let's say this is my acid, here is my neutral, and this part is basic. So my neutral is always 0. My acid is in the positive side and the negative in the negative side. Basic in the negative side, acid in the positive, and the neutral is always 0. Now, if anyone will say that what is neutralization, what is neutralization, what is neutralization, then what will you answer? Any idea, Shazan? What is
If a
neutralization?
base is mixed
Hmm.
with acid, then it becomes.
Yes, acid plus base, it gives what? Neutral. No. So if we will take one example, like for example, maths, positive what? Let's say let's take number 5. If it's positive 5 and base is what? My negative, means negative 5. Then what is plus 5 minus 5, Shazan?
0.
It's 0. So neutral is what? 0. Okay. That's why acid plus base, the positive, the addition of the positive and the negative thing is always neutral, means the 0. And for example, if let's say plus 5 and minus 3, then it will give what?
2.
Plus 2. Plus 2, right? It means here my acid is strong and my weak base, what it will give? It will produce a strong acid. Produce what? Produce a strong acid. Because here the number 5 is more than the 3. Then the strong acid, weak base, and plus 2 means positive. That's why it will produce a strong acid. So this is the like the small introduction about the what is neutralization. Now, yes. Now, do you know anything about acids and base? Acids. Any idea? Any point, Shazan, about acid? Acid is bitter in taste or sour?
Acid is bitter.
Acid is bitter in taste.
No.
Okay. Wait. If you will taste this lemon or this orange, so what's the taste of lemon? It's bitter.
Ma'am, it's not bitter. So,
Then what it's? Huh?
wait, I have to tell
What?
I don't know. I forgot the.
You forgot the taste of a lemon or orange or
Ma'am,
this imli?
It's sweet kind of.
It's not sweet. It's sour taste. No, sour.
Oh yeah, sour. I thought it was saying salt.
No, sour in taste. And what's the taste of this basic acidic taste is this, and basic taste is
It's bitter.
yes, it's bitter. For example, if we will taste this soap, it's a bitter in taste, है ना? Now,
I have never tasted it.
you never taste this soap?
No, I have never did this thing.
Oh, okay. But you should taste.
Probably it will not be tasty.
Yeah, it will not be tasty, but you will get to know the taste of the basic now.
No, ma'am.
Okay. Okay, so what is this? This is what? What's written here?
Vinegar.
Yes, vinegar. And vinegar is acetic acid.
Miss Basic.
है ना? Some naturally occurring acids. These are the naturally occurring acids. Naturally occurring acids. So this is a vinegar. Vinegar Vinegar is having a property of this acetic acid. This is what? This is what,
Wait a
Shazan?
minute.
Huh? Huh. And what's the and the ace? And this is which kind of acid? Any idea?
No, ma'am.
No idea?
No.
Tartaric acid.
Oh.
Okay. And this is what? Orange. Orange is what? Citric acid.
Citric acid.
This is tomato. है ना? And tomato is which kind of? Oxalic acid.
These all I've studied in class 6 and I forgot. It's 3 years.
Why you forgot? This is lemon.
I'm like in class 6, I don't used to study much, but now I do.
Oh, okay. And okay, tell me about lemon.
Is it again acetic acid?
Yes.
Citric.
And what about this? Milk?
Milk is acidic.
Lactic acid?
Yes, yes.
Yes. So these are what? These are the
The
naturally
name of all the acids I just gonna write.
what?
Ma'am, I want to write all the names of the acid.
You want to write?
Yes, ma'am. Give me 2 minutes on this one.
Okay, so should I wait? But I'll
Ma'am, I'll just complete in 2 minutes. Just 2 minutes.
what?
I will just write it in 2 minutes.
Okay, okay. But I will provide you the notes, the PDF.
After oxalic acid, what is something?
Okay?
Yes, ma'am.
Okay, so now what is this? This is soap, and these are all acids, acidic, and these are all basic. So this is what? No, sorry, this is different. This is baking soda. So baking soda is again basic.
Basic.
Okay, this is the litmus paper. Now, first let me write here, then you will get to know.
Ma'am, litmus paper is used to test acid means the chemical is basic or acidic.
Yes, bitter in taste. Now, you already know the examples of acids. These are the examples. Okay, these are the examples of basic. Now, if we put a blue litmus in acid, then what will happen? It will turn into which color? Any idea?
Ma'am, blue litmus in.
No.
No, I'm asking what's the question.
Okay, you're asking what's it. See, here, if this is my blue litmus paper, okay, and if I'm dipping this blue litmus paper in acid, then what will happen? It will turn into which color?
Red, ma'am, red.
It will turn into red color. And if we are dipping the red litmus in the basic, then it will turn into blue color. Okay, this one turns red litmus into blue color. This is blue and this is red. No one joined yet. Okay, so if red litmus is dipped into acid, then it will be in which color? If red litmus is dipped into acid, then it will be which color? It will be in the red color or in the blue color?
For acid or base?
No, just I'm asking if red litmus is dipped into acid. Red litmus.
It will be red only.
It will be red only. Yes, it will be red only. And if this red litmus is dipped into this basic, it will be blue. Okay, so this part you understand. Now, the next part is...
Ma'am, actually, litmus paper is of two colors. One is for red and blue.
Yes, red
is there anything else except acid, base, and salt?
Except acid, base, and salt means?
Yes, ma'am.
What?
Any other
pH value?
Yes, ma'am.
Yes, pH value is also there. We'll get to know this. Here is the pH value. This one.
Yes, I'm talking about this one.
The acid part.
Yes, ma'am.
Basic.
It was there in my 6th class.
Total 14 colors. 7 is the neutral color.
Yes, ma'am.
This is the 14 number is the strong basic. Hello, Ruth. This 14 is the strong basic. The 0 is the strong acidic. And if it will come into 3, then it will be a kind of a weak acid. Okay, we'll learn all this. Ruth, today we are discussing the new unit of 10th, acid, bases, and salts. Okay, so what is acid? Acid, what's the taste of acid, Ruth? Any idea? Hello, am I audible? Yes. What? Bitter. Okay. Okay, so what's the taste of this lemon? Yes. And the basic taste is bitter. This, like baking soda or your soap. If you will taste a soap, then it will be the taste of some bitter. Okay? This is what? This is vinegar. This is acetic acid. This is what? This is what? Shazan, what is this?
Which one?
This one.
Ma'am, it's tamarind.
This is tartaric acid. This one is orange citric acid. The tomato oxalic acid. Lemon again citric acid, and the this milk is a lactic acid. And here this is soap and baking soda. These all are the basic. Now, do you know what is a neutralization, Ruth? Any idea about what is neutralization? What is neutralization? Any idea? See, what is this? Here is the addition of the both the acid and bases, and then we'll get the neutral. Acid is mostly of the positive side, basic is of the negative side, and the neutral is always zero. For example, if we are mixing the plus 5 and the minus 5, will get the 0, means neutral thing we are getting. And if we are adding the plus 5 and minus 3, it will be plus 2, means here is my strong acid, my weak base, and again we are producing a strong acid. Okay, now do you know ki if we will dip a blue litmus into acid, it will turn into which color? The red or the blue? Rudra? Okay, let it be. See, now the next point. Shazan, if we will if we will dissolve in water to release H plus ions. And here if we will dissolve, Shazan, if here we will dissolve in water, it will release what?
I really don't have any idea. Ma'am, is it H minus ions?
No, not H minus, OH minus.
Oh, okay.
Oh, yes. Okay, let's now try some equations because equations is very important in chemistry. Now, let's do for acids. If we are dissolving, what is, can you name some of the acids, Shazan? Like hydrochloric acid, the sulfuric acid, any more acids? Do you know?
Yes, ma'am. Ma'am, lactic acid.
What is this?
Ma'am, HCl hydrochloric acid.
Yes. What is this?
H2. Ma'am, I never.
You don't know?
Sulfur.
Sulfuric.
Okay, sulfuric acid. Yeah.
This is hydrochloric acid. Hydrochloric acid. And what is HNO3? What is this? Nitric acid. Now, H2CO3. Any idea, Shazam?
Ma'am, no, wire classics complex questions.
Don't know? Okay, this is carbonic acid. And what is H3PO4? This is the P1. You already know the phosphoric, C, carbonic, N, nitric, S, sulfuric.
Ma'am, that's phosphoric acid, ma'am.
Phosphoric acid. So if we are mixing, if we are dissolving, see, dissolve in water to release H plus ions. Now, if we will dissolve this acid into water, it should release H plus ion. So what it will be? It will be H plus plus Cl minus, means it's releasing H plus ion. Now, if we are dissolving this sulfuric acid into water, it will be H plus plus SO4 minus. Here also it's releasing H plus ions, means okay, this point is valid. Now HNO3 nitric acid, if we will dissolve this nitric acid into water, again it will release H plus ion and it will be NO3 minus. Here the carbonic acid, if we are dissolving, it will again release H plus and it will be CO3 2 minus. And here again,
I mean the first one, what will it release?
What? It will be H plus and Cl minus.
Okay.
And here in the H3PO4, H plus and what it will be? Any idea, Rudra or Shazan? No, only Rudra. See, if we are dissolving this phosphoric acid in water, it will release H plus and surely it will relieve H plus ion. And what will be here? Like here it's CO3 2 minus, here NO3 minus, SO4 minus, Cl minus.
CO3 minus CO.
Minus CO.
No. It is CO.
No, why
CO3 4 minus.
CO3 4 minus CO3 4. But why this here is P na phosphoric?
I don't know.
PO4 3 minus. Here it's already PO4. Only you have to write this 3 minus.
Ma'am, I saw that PO4 is CO.
Why CO? Here in this carbonic it will be CO3 2 minus.
I'm so sorry. I saw it wrong.
Oh, Google.
No, ma'am, really. You know what? There is a pattern in that CO2, 3, and minus I discovered a pattern in that.
Okay. So it will be this. Now, for if we will write some chemical equations for basic, it should be what? It should release this OH minus ions. So what is the basic? What is this? NaOH? What is the full form of this NaOH? Any idea? Rudra, are you there? What is the full form,
Yes.
Shazan, of NaOH? Okay, Rudra, will you tell me?
Sodium hydroxide.
Yes, sodium hydroxide. Sodium hydroxide. Again, my KOH, my CaOH, and my MgOH twice. What is this KOH?
Potassium hydroxide.
Which one?
Second one, potassium.
Potassium. Okay. And the third one?
And third one is calcium hydroxide.
Yes. And this one? Mg.
Mg, wait a minute. Full form of Mg. What was it?
Full form of Mg is what? Magnesium.
Magnesium hydroxide.
Magnesium hydroxide. And again, if we are mixing this NaOH with water, it should release this OH minus, है ना? Dissolve in water to release OH minus ions. So if we are dissolving this sodium hydroxide in water, it should release the OH minus plus Na plus. This is NaOH, so Na plus and OH minus. And here for KOH, what it will be K plus, and again OH minus, means it's releasing OH minus. And here if we are dissolving this calcium hydroxide, it will be Ca. It will be what? It will be what? Ca plus or Ca2 plus? Ca2 plus. And for this magnesium hydroxide, it will be Mg2 plus plus OH minus. Means all are, means this point is valid. And here these are the, this HCl, H2SO4 and HNO3 are the strong acid. These are the strong acid. And these two are the weak acids. And here in this basic, these three are the strong basic and this is the weak. Okay, any doubt till now? Okay, so let me ask you a question from Rudra. What is weak acid? What is weak acid? Any idea about weak acid?
Ma'am will have less H plus ion.
What? It will have less H plus ions. Good. Less H plus ions. And strong acid means it will have more enough H plus ions. And here in this weak basic, it means it will have less OH minus ions. Okay, Shazan, what is weak basic?
Ma'am, weak basic, you're asking me. Ma'am, will dissolve in water.
Okay, it will dissolve in water, but what is weak? Weak basic. Why we name it as weak?
Ma'am, it's not that reactive.
It's not that very good. No, yeah, because it's having less OH ions.
Okay.
And what is strong and what is weak acid? It will have a less H plus ions, because while dissolving in water, they are releasing H plus and OH minus. So if we will write here the weak basic, it will have less OH minus, and weak acidic, it will have less H plus ions. Okay. Okay. Now let's go through this notes. Okay, wait. These are the chemical properties. These are also very important, like reaction with metals, with metal oxide, with chlorides, with nitrates. First, let me ask what is alkali? Alkali is acid or base? Acidic or basic? What is alkali? What is this? Shazan, any idea? Shazan, will you please Google and tell me what is alkali?
Ma'am, why did you do I don't Google it, ma'am. If I know, I answer. If I don't know, I don't answer.
Okay. Alkali are bases. Okay, alkali are basic in nature.
Ma'am, strong bases, ma'am. And ma'am, first of all, I studied it in 6th class.
Okay, no issue. Alkalis are.
And ma'am, I don't Google.
Okay. Alkalis are basic in nature. And here what? Water, alkalis are bases, means like basic in nature. And water soluble bases are called alkalis. Water soluble bases. What do you understand by water soluble bases? Rudronial, any idea what is water soluble bases? These are special kind of basic. Like special base.
Ma'am, is it soap? Soap is water soluble.
So but here the example, any example? Soap. Okay. Sodium hydroxide, NaOH, the potassium hydroxide, calcium hydroxide. These all are the examples only. No, these are because alkalis are what? Alkalis are water soluble. And here my NaOH, KOH, CaOH, Mg twice, MgOH twice, all are what? All are dissolving in water to release this OH minus ion. So here, if I'm asking what is alkali, alkali are basic in nature. And what do you understand by this water soluble basis? Means it's dissolving in H2O to release this OH minus ion. So example should be this only, the sodium hydroxide, the potassium hydroxide, or the magnesium hydroxide. Potassium KOH or MgOH twice. Okay. All bases do not dissolve in water. Only the alkali is a base that dissolves in water. These are the alkalis that dissolves in water to generate this OH minus ion. They are soapy to touch. What is the nature of the alkali? They are soapy to touch, bitter in taste, and corrosive. Corrosive means hard. Soapy to touch means like some sticky kind of thing. They are bitter because basic are always bitter, and the corrosive means hard in nature. They never taste or touch them as they may. The alkalis, like if we will touch the sodium hydroxide, the potassium hydroxide, what will happen? Shazan, what will happen if we will touch the sodium hydroxide
My
or the
skin will
magnesium?
burn
It
because
will
it's
harm
very
us, right?
hard. It means that strong acid, ma'am.
These are the strong acids, so they will harm us. So
Yes, ma'am.
we never touch these kind of basics, means the alkalis. Now you understand what is alkali? Okay, any example? Okay, let me write you the chemical equation. See, if this acid plus base will give me what? Salt plus water. So the example, so the chemical equation of this alkali should be, acid is what? Acid is my hydrochloric acid. And if I'm writing the base, means let us take this sodium hydroxide, means NaOH. It will be salt, NaCl, NaCl, and this will be H2O. This is a kind of double displacement reaction. Double displacement reaction. Okay. This is the chemical equation of this alkali. If we are adding the acid and base, will get the salt and water. Like here, if we are adding the hydrochloric acid and the sodium hydroxide, we are getting salt as NaCl and the water H2O. Okay, Shazan?
Yes, ma'am. Can you just explain once again?
Okay, so this is the chemical equation. If we are adding acid and base, then we will get the salt and water. So my HCl is acid, my hydrochloric acid, and if we are taking base, for example, let us take this sodium hydroxide, NaOH. So it will give me what? The salt, means Na will combine with Cl, and H will combine with this H, means it will be H2O, the water. Okay, this is a kind of chemical properties between the acids and base. This is a chemical property. Chemical property, like here, see, this is a chemical property, but here it's starting from the reaction with metal oxide. This is the very simple chemical equation. If we are adding the acid and base, we'll get the salt plus water. Okay, this part understood. What is alkali?
Yes, ma'am.
Okay, so what is alkali? Shazan will tell.
Yes,
Shazan,
ma'am.
what is alkali?
Ma'am, alkalis are
Hmm.
substances which are acidic or basic in nature.
Acidic or basic?
No, basic in nature. Yeah.
Okay. Huh.
There
Okay.
are two types of alkalis. One is strong alkali and one is weak.
Why two type of alkali? Okay.
Ma'am, one is strong.
Okay, but there is okay. Tell now. What's the nature of this alkali?
Ma'am, it's basic.
It's basic. It's bitter, soapy to touch, and the corrosive. And what is the example? Why we are saying that water soluble bases are called the alkali? Come on, tell. Why we are writing this point? Water soluble bases are called alkali.
Ma'am, because alkalis are soluble in water. They dissolve in water.
Yes. It dissolves in water to produce this OH minus ions, and the example of the alkalis are this only, the sodium hydroxide, potassium or magnesium, because if we will dissolve this in H2O, it will give me Na plus and OH minus ion. Okay, now let us study this, the chemical properties of acids. Okay, first let me write my, okay, here, chemical properties. Chemical properties. Here it will be for acid and here for basic. If acid is reacting with metal, then what it will form? If acid plus metal, it will form salt plus hydrogen gas. Acid plus metal, if acid will react with metal, it will form salt plus H2 means hydrogen gas. Okay, let's take one example. Can Rudra, will you give me the example or the chemical equation of this? Like acid plus metal is giving the salt plus hydrogen gas. Any example?
I'm not sure.
You are not sure? This is easy, no? For example, for acid, if we are writing this hydrochloric acid, what is metal? Let us write about this zinc. It will give us the salt, means ZnCl2 plus H2. Easy. And here for basic, we will write, here it's acid, so it will be basic over here. Basic plus metal will give salt plus H2, hydrogen gas. Now, Shazan, now any chemical equation for this? Basic plus metal will give salt and hydrogen gas.
Ma'am, you are asking me.
Huh?
Ma'am, don't.
Any basic thing. H2SO4 plus
Ma'am, it's
metal,
basic.
zinc. What?
Ma'am, H2SO4 is basic.
Yes. It's basic only, no?
Sulfuric acid.
H2SO4.
Ma'am, H2SO4 is sulfuric acid.
Really?
Yes.
Yes, very good. I was just trying to confuse you. Okay, you got it. Now here. So you tell me any basic thing. Let us take this NaOH or sodium, anything. If we will write this NaOH here plus metal zinc.
NaCl is also base.
What?
NaCl is also base, ma'am, salt.
Huh? Then it will be here what?
NaOH is ma'am.
NaOH is basic na, sodium hydroxide.
Sodium hydroxide. No, I was asking the full form of NaOH.
Sodium hydroxide. So if this will react, the sodium hydroxide will react with zinc, it will be Na2ZnO2. If we will balance this equation, then we'll get this Na2 plus ZnO2 plus H2. Na2ZnO2 is sodium zincate. This is sodium and Zn is zinc, and here the O2 is there, that's why sodium zincate. Okay, now this is what this is. Now let us see here. See, if this metal is reacting with the acid, it will get the salt, will get salt here and the hydrogen gas. Metal, for example, zinc, and the acid is hydrochloric acid. It will be ZnSO4, zinc sulfate, and the hydrogen. And here, if the metal, we will take iron, and again the hydrochloric acid HCl. Here my equation is balanced. That's why that's why here we are getting 2 and 2. Okay, so it will be FeCl2 and H2. Okay, the hydrogen gas will be there and the salt will be here. So ferrous chloride and the zinc sulfate. Okay, now okay, most important thing, most of the compounds of metals are basic in nature, and most of the compounds of metal are basic in nature, and most of the compounds of non-metal are acidic in nature. Like here, if we are writing zinc, so zinc is what? Zinc is a metal, so it should come in the basic thing. So this is only the important note you can say, that most of the compounds of metals are basic and most of the compounds of the non-metals are acidic in nature. Since the sour substance and curd are the sources of the acids, the acid present in them may react with the metal of container. So these substances should not be stored in the metallic container. Now let's do the another chemical reaction, the reaction with the metal carbonate or metal bicarbonate, but here it's with the metal oxide. Okay, first let me this part you understand, Shazana and Ruth. the acid plus metal is giving the salt plus hydrogen gas.
Yes, ma'am.
Okay. Now next chemical equation. Next is with acid plus metal carbonate. Acid plus metal carbonate, or we can say the metal bicarbonate. First we will write the chemical equation for this metal carbonate, and the next we'll write with this metal carbonate. And he, okay. So any equation, any hint, any example? Rudronial or Shazan?
I'm thinking.
Okay, think. It will give us salt. Here also salt and hydrogen gas. It will give us salt, hydrogen gas. Sorry.
Salt, CO2, and it will give CO2.
CO2 and H2O. Water and carbon dioxide. Now, any example? Think and example for? Example for this, the acid metal and this carbonate is giving the salt plus this water and the carbon dioxide. Let's take the very basic acid, the hydrochloric acid. Okay. And let us take this metal carbonate, Na2CO3. Metal carbonate is Na2CO3. Now, what we will get? We'll get the simple NaCl plus H2O, H2. O, and here it will be, if O is adding with this H, then it will be what? Only two O is left. That's why CO2. And if we will write example for this metal bicarbonate, then it will be HCl. And for bicarbonate, we use NaHCO3. It will be NaCl plus H2O plus CO2. Only the difference is in the balancing part. Okay. Now, this is what? This is with the acid plus metal is giving the carbonate. Sorry, acid plus metal carbonate is giving the salt plus water plus this carbon dioxide. Now, here is with the reaction with the metal oxides. Metal oxide is what? Acids react with certain metal oxides to form the salt and water. To form the salt and water. Yeah, this only. To form the salt and water. But here there is not a carbon dioxide because it's with only the metal oxide, and there we are writing the equation for the metal carbonate and the metal bicarbonate. Okay, now let me, it's already 44. Okay, now, so, okay, just a minute. To test CO2, do you know what is lime water? What is lime water?
It's lemon and water.
What is the equation of this, like the formula of the lime water? No? Water is what? H2O. And lime is what? CaOH twice. Okay?
Okay.
So here the carbon dioxide is extra. So to test the carbon dioxide, we should pass it from the lime water. The slaved lime, we can say. If we are passing here, for example, this is my lime water, LW, and here if it, here is my CO2, then earlier it will be in the transparent color. But if we will pass the CO2 from the lime water, it will turn into milky. Okay, see this thing. If this is my lime water and this is my lime water, if we are adding, if we are passing the lime water with this CO2, if we are to test the CO2, we should pass it from the lime water. It will turn into milky in color. Okay. Earlier it was transparent, but by passing the carbon dioxide, my lime water turns milky. And if we will again pass a very excessive amount of this carbon dioxide, again it will turn into transparent. If we will pass it from the very excessive amount of this CO2, again it will turn into this transparent color. It's already 46. The recording is there. Okay, so then understood this all part. In the next class, we'll go through this lime water. Okay, the lime water, the strong acid, the weak acid, the indicators, the olfactory, the universal indicators, and all. Okay, so this part understand what is acid, what is basic. These are the acids. These are the strong acids. This one, the phosphoric acid is the weak acid. These are the basic. And here the chemical properties, some of the chemical properties, what is alkalis, and these are the chemical properties. If we are reacting the acid plus metal, it will be salt plus hydrogen gas, and here if we are reacting this, it will be carbonate and the bicarbonate. Okay, And this part is very important. Here in this lime water, if we are passing this lime water with this CO2, it will turn into milky in color. And again, if this lime water will pass it from the excessive amount of carbon dioxide, then again it will turn into a transparent color like this. Okay, Shazan, any
Yes.
doubt, Rudronial, any doubt anywhere?